Hi guys, I'm here for just a quick, I'm hoping it's less than 5 minutes video, just for some homework help, just to explain why things are the way they are. I'm hoping that you're at home, not just copying the key, but you really want to understand why that null hypothesis is what it is. So I'm going to go through number 2, and I believe I'm going to go through number 4. Okay, so on number 2, your teacher claims to produce random numbers from 1 to 5, inclusive, meaning 1 is included as well as 5 on our calculator. But you've been keeping track. In the past 80 rows, the number 5 has only come up 80 times, or 8 times, excuse me. You suspect the calculator isn't producing enough 5s. Okay, so what you're doing with this state process, again, just a reminder, 3 things, that P, that null, and that alternative, okay? So first, telling the story. What is this story about? This story is talking about the true proportion of times a 5 will come up when she's doing this calculator process. Okay. Now we need an HO and we need an HA, right? And we have that P. Now, what is the probability? What is the claim? What is the current truth? They don't give you a current truth, so you have to figure it out, or it's not explicitly stated, excuse me, okay? If something's random, that means if I'm going to produce numbers 1 through 5, they all have to have an equal chance of coming up, right? So if I'm going to produce, it'd be like if I had 5 numbers in a hat, what's the probability I pull out a 1? Then I replace it. What's the probability I pull out a 2? Those are all equal, right? So that would be a 1 out of 5, 1 out of every 5 times in the long run, we should be getting a 5. Well, it looks like that didn't happen. 8 out of 80 doesn't look like that happened, but we don't care about that 8 out of 80 right now. That's our evidence. That is not what should happen, the current truth or the current claim. Okay, so what should happen is it should come up 1/5 of the time. Now, what are we trying to prove? We're suspecting the calculator isn't producing enough 5s. So we're trying to find evidence if this is true. So if we're not producing enough 5s, we're trying to find evidence that it's less than, right, what we think it should be. So that's why it's less than 1/5. Okay, next one I'm going to go through is number 4. It's one that's similar to this. Just trying to see. The rest of them, I think they give them to you. So, all right, number 4. You have been using a random digit table all year, but one day you decide to check out its randomness. You count the number of times the digit 9 occurs in the last 4 rows of the table and find that there are only 12 9s in the last 160 digits. You suspect the table is flawed by having fewer 9s than it should and decide to do a significance test. Again, same thing here. What is this story about? The true proportion of times that a 9 comes up on a random digit table, and you've seen that in stats this year. Well, if something is random, remember, we have 0 all the way to 9. That's 10 numbers. You can imagine it if I had 10 numbers and had shook it up, pulled those numbers out, just like the last one. A 9 should come up 1 out of 10 times. Why? Because there's only one 9 from 0 to 9 out of 10 total. Okay, so our current truth as we know it is P is equal to 1/10. What are we trying to prove? Because we think it's fewer, we say P is less than 1/10. 3 minutes and 40 seconds, guys. I did it. I hope y'all are having a great day, staying safe and healthy, and hope this helped with your homework a little bit. Take care.